Stoichiometry, this is putting together everything that you have learned in your Chem 1 class up to this point. You need to use all your skills from balancing equations to writing formulas to doing dimensional analysis, all wrapped into one. First thing you need is a balanced equation. Make sure that whatever equation you start with is balanced. Here we can see that I've got an example equation and it does balance. What you need to realize is that these coefficients here for each of the compounds, those refer to how many moles of a substance you have. Okay, so I have 4 moles of aluminum reacting with 3 moles of oxygen, and this produces 2 moles of aluminum oxide. And from this we can get a lot of different ratios. We can see that for every 4 moles of aluminum that I use in this equation, I also use 3 moles of oxygen. So I can set up a dimensional analysis problem with this factor. You can see there's also 3 oxygens for every 4 aluminums. It works back and forth. And you can go ahead and do that just saying that however many I have of this, I have that many of the other element there. Okay, you can set up all of those. Also, we can use mass. We can say that, hey, every aluminum I have, if you look on a periodic table, it would be 27 grams of aluminum. Oxygen is 16 for 1, but 32 because it's O2. Pay attention to diatomic elements in your equation. Okay, these are O2s. They weigh twice as much as single oxygens do. Okay. So it's important to be able to take a look at this equation and see all the ratios and know how to take the mass of any of the compounds or elements. Once you understand that, it's basically putting together everything that we've learned from mole conversions, and you're just converting between 2 different substances this time. Okay, if you think about it, when you just did mole conversions, they would give you something like 6.95 times 10 to the 22nd particles of something, and they asked you how many grams would that weigh. Well, you had to take that particles, set up your dimensional analysis, divide by Avogadro's number, that puts you into moles of the substance. Then once you were in moles, you can say that, well, 1 mole on the periodic table, find the mass, and you convert it, and then you go from particles to moles to grams. Okay. We're doing the same thing with stoichiometry. Stoichiometry is using this equation to express one compound in terms of another. Okay. So in order to do that, we can only compare things in an equation when we are in moles. Okay. I can't say grams of one substance directly to grams of another, but once I'm in moles, I can go there. So whatever is given to us in the problem, you make sure that you go to moles of that substance first, and then you jump on over to moles of the second substance, and then from there you can just convert to whatever the problem was asking you for. Okay. So I've got a few example problems right here. Remember, the first thing is you make sure your equation is balanced, and this is a balanced equation, so we are good to go. Always take a look at what you are given and figure out what you are looking for. So in this problem, when 62.0 grams of fluorine, they gave me this amount right here. This is my given. That's where we'll start. When this is reacted, how many moles of nitrogen trifluoride? Okay, so this is what we want to know. So the game plan is that we are given grams of fluorine this time, and we want to know about moles of this compound. Okay, so remember, we can't go directly from grams of one compound straight to moles of the other. Okay, I don't have a way to get there. So my game plan is I'm going to go from grams of the first substance to moles of it. Then I can continue on to moles. So start with the given. 62.0 grams of fluorine. Don't forget fluorine is diatomic. It is F2. Okay. Make sure that we can cancel out the units that we don't want. We don't want grams of fluorine. We want moles of nitrogen trifluoride. So grams says figure out the mass from the periodic table. So you can see right here, fluorine has a mass of 19.00, but there are 2 fluorines, so you must multiply 19.00 times 2, and that'll give you 38.00 grams of F2 is in 1 mole of F2. My grams cancel, so I'm now expressed in terms of moles of fluorine, and I see that once I'm in moles of one substance, I can go to moles of the other one directly using the balanced equation. That's where the coefficients in this equation come in. So I find moles of fluorine. Well, this thing tells me that there are 3 moles of fluorine for every 2 moles of nitrogen trifluoride. Canceling out the units that aren't needed, we are now in moles of nitrogen trifluoride, which is what the problem asked us to solve for, so we can put this into our calculator. Again, all you do is you are multiplying everything across the top and dividing across the bottom. If I can get my calculator to turn on. Alright, so it's going to be 62 at the top. Number at the bottom says divide by 38. Now I have a number at the top, so we'll multiply by the 2, and I have a number at the bottom, so I will divide by the 3. Okay? So remember, just take a look. Put the first number in, and then go from left to right. Any number that's at the bottom, you hit divide by before it. Any number that's at the top, you hit multiply before it. Once you have them all in, you hit enter. And I'm given this answer. Significant figures are very important here. Don't use the number of moles in the middle of a problem to determine your significant figures. It's only the measurements that count. Here I have 1, 2, 3 significant figures, and I used 4 here, so 3 is what I'm going to need. So I'm rounding this to 1, 2, 3 places, so we will call this 1.09 moles of nitrogen trifluoride. Okay. Let's take a look at the second problem. How many molecules of N2? Okay, so this is what we want to know. We don't know this. How many of those are needed to produce 2.85 grams of nitrogen trifluoride? So we were given 2.85 grams NF3. Okay. So let's get a game plan here. We have grams of NF3. So we have this right here. We have mass of nitrogen trifluoride. Okay. And we want to know about molecules of nitrogen. So that's the other substance, and molecules are particles. So we want to know how many of these we have. So in this problem, we're first going to have to convert to moles of nitrogen trifluoride. Then we're going to have to convert to moles of nitrogen, and then continue on to number of particles of nitrogen. Okay, so that's our game plan. We have grams of nitrogen trifluoride. So let's go ahead and be able to cancel this out. We have to figure out how many grams from the periodic table. So taking a look right here at our masses, we see that, all right, 1 nitrogen is 14.01, plus we have 3 nitrogens, and each of those has a mass of 19. So 71.01 grams per mole for nitrogen trifluoride. That was 71.01. That is 1 mole. Cancel out the grams. We're now in moles. So once we're in moles, we're good. Once you're in moles of one substance, you can go to moles of the other by taking a look at the equation. Okay, so I am trying to go from here to here. So when I set up my conversion factor, I'm going to use 2 for the nitrogen trifluoride part, and I'm going to use a 1 for the nitrogen. If there's not a number there, it means a 1. So I want to use the nitrogen trifluoride here to be able to cancel it out. So it'll be 2 moles nitrogen trifluoride and 1 mole nitrogen. Those units cancel. So now I'm in moles of nitrogen, and once you're in moles of a substance, you can go directly to any other information about it. I can convert to particles or liters of gas of it, or grams. Well, this time I want particles, and particles says use Avogadro's number. So I'm going to set my conversion factor up so that my units line up and I can cancel them. Since I have a mole of nitrogen here, I make sure and use 1 mole of nitrogen at the bottom, and then opposite of that will go my Avogadro's number. Oops, 23rd. Molecules N2. All right, make sure you do not confuse molecules with moles. They're similar looking, but this is those small things that make up elements, and this is a whole lot of them. Okay, they're not the same. Okay, my units have canceled. I am ready to go ahead and solve. So again, start by putting the first number in the problem, 2.85. Something at the bottom says divide, so divide by 71.01. Next number is also at the bottom, so I divide by 2. And then the next number I had was Avogadro's number at the top, so I'll multiply by 6.02 times 10 to the 23rd. Hit enter, and I am given this answer. Must use the correct number of significant figures. 1, 2, 3 is what was given in the original measurement, so I'll use 1, 2, 3. So we will call this 1.21 times 10 to the 22nd molecules of nitrogen. Okay. And one more problem. This time we are given grams of nitrogen, so that's given, so we know we're going to start with what's given. Okay. And we want to convert to grams of fluorine. That is our unknown. We'll know we're done whenever I have grams fluorine left. Okay, so let's take a look at our flow chart. We are going from grams of one substance to grams of the other. Okay, so we are starting here, and we're going to end in grams of the other. So our game plan is we are going to convert to moles of the first substance, use the equation to convert to the moles of the other substance, then I can go ahead and convert to grams of the second substance. Okay, so 3.54 grams of nitrogen, which is diatomic. So I have to have grams of nitrogen here to cancel out, and that'll be 1 mole of nitrogen. Where are grams found? The mass on the periodic table. So I know that it's 14.01 is the mass of one nitrogen atom, but it's diatomic, so N2, 28.02 grams. Cancel out my grams. Don't need grams. Now the unit that I have is moles of nitrogen. So I'm in moles of the substance, and remember, moles is good because moles I can go directly to the other substance just using my equation here. So how many moles of nitrogen do I have for every mole of fluorine? Well, I see I have 1 nitrogen for every 3 fluorine. So this is my conversion factor I'm going to use. I just need to make sure and line it up correctly. I had 1 mole of nitrogen for every 3 moles of fluorine. Cancel out the units. Now I have moles of fluorine. And once I'm in moles of the substance, it's easy to convert to grams of it. Just look on the periodic table and say how much is in 1 mole. Well, if I have 1 mole of fluorine, I look on the periodic table, see fluorine is 19.00, but it is diatomic, so 19 times 2 will give me 38 grams per mole of N2. So this will be 38.00 grams of nitrogen. So the unit that I want is what the problem was asking for, so that means that it is time to solve. So I have 3.54, divide that, because it's at the bottom, 28.02, multiply, because the next number is at the top, and then the last number is also at the top, so that is multiply again, 38. Okay. So here's what I have, and there were 3 significant figures, the smallest measurement that I have. So 1, 2, 3 is how much of this I use. This would be 14.4, correct unit, grams of nitrogen gas. Okay. So that's all this really is. Stoichiometry is just making sure your equation is balanced, making sure that you first convert to moles. Okay. Wherever you are, make sure you're going to moles, and then once you're in moles, convert to the other substance and continue simple mole conversion to whatever you need.